Do you think this is Earth? No, it's not Earth. That's Mars. This is Marina Canyon, flooded with water. And it's not our fantasy that this is Mars' past. It's a scientific fact. Many argue whether Mars can become a second home for humanity. Where to evacuate to if anything happens. After all, Earth's problems are known. But before we can decide if Mars can be a safe haven, we need to investigate. We need to figure out what happened to the planet in the past. Who hurt it so much, took away the forests and seas, blew away the atmosphere. But really, how long can we wait for these evil Martians with tripods to visit us? It is time to fly to visit them. So, to Mars. We're setting up an expedition. We're going on a space voyage. Our flight is not a fairy tale or a fantasy. It is a kind of thought experiment based on objective scientific data. The Martian race has begun, and you and I become its participants. But all the secrets of the investigation lie ahead, all in good time. Meanwhile, we're on Earth, the night before liftoff. Stuffy August, lots of stars. And here is one bright star with an orange hue. That's Mars. It is the third brightest star in our sky. But we can observe such a picture once every 2 years, when Mars is closest to Earth. This is the moment on the model. Mars and Earth are on the same side of the Sun, and the distance between the planets at this moment is minimal clearly. This is the most favorable time to fly to Mars. The window of opportunity, or starting window. We have to launch with some kind of anticipation. Here, for example, from this position of Earth, to get to this point. That's where we'll meet Mars. The distance we have to travel, as you can see, is more than 55 million kilometers. That's almost 500 million. And it will last about 7 months. The dream of going to Mars has a long history. Ancient Egyptian astronomers studied Mars 2,000 years ago. Chinese records of the motion of Mars are 1,000 years BC. In ancient Rome, the planet was named after the god of war precisely for its red-orange hue. The first time Galilei Galilei looked at Mars with an armed eye was through a telescope in 1610. And he recorded light polar caps and dark spots on the surface. One was very large. Italian astronomer Giovanni Schiaparelli called this dark spot the Big Sirte 200 years after Galilei. The same astronomer Schiaparelli saw extended straight lines on Mars. They formed intricate patterns. Channels. Schiaparelli gave these lines their name. And noted that the approximate width of each channel was about 100 kilometers. It was a sensation. Mars, not so formidable. In fact, it's about half the size of the Earth. and not at all red. As it turns out, well, having dodged a meteorite, we begin our search for answers to the main questions of our mission. What happened to the planet, and did Mars really have its blooming past? What catches your eye? Canyons, volcanoes, and craters. Look at this, an interesting configuration of four large objects. Let's open the altitude map. The red areas here are high, the blue areas are low, and the white areas are very high. Let's start with the largest object, Mount Olympus, the highest mountain in the entire solar system. Almost 3 times taller than Everest. What made it so huge? Huge even compared to the size of the planet. We'll find out a little later. Three sites near Olympus are volcanoes. Mount Iskria, Mount Peacock, and Mount Rc are mountains of the province of Farsaida. All of these volcanoes are silent today. No pockets are visible. Near the province of Farsaida is a giant labyrinth of canyons, poetically called the Labyrinth of the Night. And the Labyrinth of the Night, in turn, is part of the Marina Valley Canyon system. At the beginning of the film, you saw this valley as if in the past, filled with water. And to the question of canals, could this canyon system here have seemed like canals to astronomer Giovanni Schiaparelli? Quite so. From orbit, the Marina Valley seems to literally cut through the planet like a fissure. So why are these formations, Olympus, Marina, so huge? To get closer to the answers to all our questions, let's look for a place to land. Here's a good place nearby the giant low ends of the plain of Chryse. Here, by the way, the first earthly space station, the descent module of the American Viking 1 spacecraft, made a soft landing. It happened in '76. Let's try to land here, too. Here are pictures of our landing site, Chryse Plain, the first photos of the surface of our neighbor. They were taken by the Viking 1 station. Such a reality opened up a solid rocky desert. But look at this boulder. Do you see it? It looks quite rounded at first glance, doesn't it? Could it be the result of wind work? It could be. Or maybe the waves of the ocean. This is what food for thought the first panoramas of the surface of Mars already give us. Think about it. It's an alien planet, far, far away. And what's the temperature outside now? The Viking landed in a Martian summer, and in summer, the temperature on Mars is plus 20 degrees Celsius. But in winter it's down to minus 120, and there is nothing to breathe. The Martian atmosphere consists of 95% carbon dioxide. In addition, the low atmospheric pressure on the surface, which is only 0.5% of that on Earth, will make the fluid in the human body literally boil. We're on the surface of Mars. Of course, the spacesuit that the makers of the movie Space Flight invented in '35 looks more like a diving suit. But this is fantasy. And here's the exact calculation. A spacesuit specifically designed to work on Mars, a promising model. But there is something in common with a diving suit, isn't there? In general, the plane of Chris, where you and I landed, is located below the average level of the surface of Mars by about 2 and some 3 kilometers. The water must have flowed down there from the nearest mountains, from the ridges of the same farces. We are close by. Apparently, that's how the water behaved, flowing down from the mountains. You see how much water erosion we find here. And look how smooth the ground is right there. What does it look like? It's like the center of a stream. We analyze it and we find clay, our normal clay. This clearly proves that there was once habitable fresh water on Mars. Another rover proved that such deposits are clay after all. And it happened in 2012 in the area of Gale Crater. There, the rover Curiosity took soil samples and confirmed that yes, this is clay after all. And it's no coincidence that this happened in the Gale Crater, also a very interesting place. Look at this. It looks like a crater, but in the middle of the mountain with a pointed peak height of 5 kilometers. And it turned out that the mountain is layered. That is, it consists of layers of sediment and clay, and sulfate mineral sedimentary rocks. What does this tell us? That there could have been a lake here, and around the mountain, at the bottom of the crater, look dunes, whole rivers and even river deltas. Right now we're still in Gale Crater. Ahead, beyond the fog of dust, is the same mountain. It's evening on Mars. Over there is a ridge of rocks. Must be a riverbed, too. There are deposits of clay between the rocks everywhere. And this little sun is smaller than from Earth. Distant, and a strange blue dawn. It's the Martian dust that refracts the light so peculiarly. By the way, if modern Mars can be compared to Earth's deserts, then ancient Mars, according to scientists, was much like Iceland. With oceans, a favorable atmosphere, and a comfortable temperature regime. And in general, the same scientists estimate that billions of years ago, the ocean occupied almost half of Mars. And if so, then deposits of marine phytoplankton must be somewhere. And yes, here is a discovery. In the same Gale Crater, in soil samples found organic molecules. Or rather, their remains. The age of the find and another unusual phenomenon was discovered by the rover. It recorded that the concentration of methane in the atmosphere varies with the season. Methane is an element that can be produced both by living organisms and by geological processes. But volcanoes on Mars are dead, and geologically, the red planet is silent. And so, it may well be that methane is being produced by organic bacteria that are still alive today. This makes for an interesting picture. Add to this the presence of large polar caps, frozen water at the poles, or the recently discovered underground seas at the South Pole. Radar detected a layer of water in liquid state, at least several tens of centimeters thick there. And where there is water, there is life. What is this? Do you see that too? This is what the rover recorded. Real video footage. Looks like little tornadoes. They're dust demons. Yes, that's what the people of planet Earth called it. Demons appear here and there, and so, by the way, a dust storm begins on Mars. And Mars is notorious for intense storms. They can even be seen through telescopes on Earth. Low gravity allows the wind to raise dust clouds to a height of up to 50 Kelvin m, and winds on Mars are a daily occurrence, with speeds of up to 100 meters per second. Why are the winds so strong? Because of the same huge temperature difference between day and night. Even in summer at night, temperatures can plummet to -73, and that's from +20 during the day. The interesting thing is that although such storms look threatening, their impact force is small because of the same low atmospheric density. Wind generators on Mars would be absolutely useless, and these winds cannot knock a man down. The threat of storms is different. The ground on Mars is hard regolith, essentially crushed glass. This is what Martian dust is made of. We get the danger to any equipment. Maybe it was the dust storms that ruined the atmosphere and all life on Mars. Well, no. It's now the Martian storms that are kicking up dust almost into space. It's now the turbulent winds because of the temperature difference. And when the atmosphere was thick and the planet warm, there were no such storms. Today's Martian storms are more a consequence than a cause. And we are looking for the cause. And together with us, the Mars 2020 expedition is looking for the cause, looking for it in the impact crater Zero, located on the border of the Bolshoi-Sirt Plateau. Remember that big spot discovered by Galileo, the Big Sirt, the Perseverance rover in the world's first extraterrestrial aircraft. The Ingenuity helicopter arrived on the planet as part of the Mars 2020 expedition. The helicopter's function is auxiliary. It has to determine from the altitude where the rover should go. And the rover has a primary function, to explore the lake crater, where once upon a time, in that blooming past of Mars, there was a flowing lake about 250 meters deep. There must have been fish and phytoplankton splashing around. Scientists plan to look for traces of this phytoplankton's so-called biosignatures. A familiar story from Gale Crater. By the way, interesting information. The Russian corporation Roscosmos, together with the European Space Agency, is going to go further in the search for biosignatures. The ExoMars 2022 international mission is scheduled to drill 2 meters deep. Why is this depth so important? Let's ask the scientific leader of the Russian part of the project. Doctor of Physics and Mathematics Oleg Igorovich Korblev is online with us. If you drill down to 2 meters, you can reach the horizons where cosmic rays do not penetrate. Mars, unlike Earth, is not protected by radiation belts, and everything that arrives from space reaches the surface, as if sterilizing it. Therefore, there is a better chance of finding signs of life at depth. And this is the main goal of the mission. The insecurity of Mars. Let's remember this point and come back to our investigation. Of course, you have noticed that the entire surface of Mars is literally full of craters, and the craters are not of volcanic origin. Why is there no such thing on Earth? Maybe that's the answer to the question, what happened to Mars? Let's go back 4.5 billion years. At that time, the solar system was young and the planets were forming. This process was ruled by the growing giant planets, Jupiter, Saturn, Neptune, Uranus. They attracted too much planetary material, simplifying the story. Let's say that Mars was in the wrong place at the wrong time. It fell under the influence of the giants, on the one hand, and was too far from the Sun, on the other. It lacked planetary material, literally. Mars got the most from the asteroids as well. By the way, let's remember that not far away, right here, between the orbits of Jupiter and Mars, there is an asteroid belt. That is, Mars was indeed, alas, in the most shocking place. Moreover, there is a hypothesis according to which about 4 billion years ago, a huge body the size of the planet Pluto collided with Mars. And what could such a catastrophic impact lead to? As one answer to a significant difference in size between the two hemispheres of Mars. This is clearly visible on the altitude map. That, by the way, is why both the Marina Valley and the same Olympus are so huge. Okay, all of this happened during the formation of the planet. But what happened to the planet afterwards? After it became a blooming Mars, what could have dried up the water? Taken away the atmosphere. In fact, we're close to a clue. It's already close. It's just a little bit away. It's a compass, a remarkable device for navigating the Earth. The magnetic compass needle points north with one hand and south with the other. Now listen, friends, the compass doesn't work on Mars. No, it doesn't work. You don't have to check. And this is the main reason for all Martian problems, the magnetosphere, namely its absence. Let's build the logical chain further. So, there is no planetary magnetic field, the magnetosphere. And this is a necessary protection from solar radiation, from deadly radiation of different types. So what happens? It turns out that it is the solar wind that is one of the main suspects in the case of the disappearance of the Martian atmosphere. The flow of charged particles blowing continuously from the sun literally blew it away. Yes, Mars is not protected. We have that on record, remember? This is how charged particles from the solar wind rush into the upper atmosphere of Mars and knock the atmospheric gas ions out into space. By the way, This effect leads to the formation of a kind of induction-like magnetosphere, that is, freely formed magnetic eddies. Electric currents surround Mars in a double loop, but the decaying induction magnetosphere of Mars is not enough to protect the planet. These eddies cannot even move the compass needle. First, let's understand how the planet's magnetic field is formed. This is the planet's core. The hot material of the core goes up, and the cooled material goes down. This process is called convection. The movement of huge masses of matter induces electric currents, which, in turn, induce a magnetic field. Such a kind of dynamo under the surface. But what could have stopped it? There is a hypothesis that giant asteroids are to blame. Imagine a heavy bombardment by asteroids several hundred kilometers in diameter, and for an impressive 100 million years. This could have disrupted the process of convection, that is, heating up the mantle, mixing up where it is hot and where it is cold. In its normal state, the cold mantle draws heat away from the core. Keeping the hot matter moving upward, but with a heated mantle, that balance is thrown off. And without this main flow, convection stops and the magnetic field disappears. The theory is consistent with the observation that only the oldest impact craters on Mars are magnetized. According to calculations, the death of the global dynamo of Mars occurred around the same time that the planet was shaken by the very destructive impact of a huge body the size of Pluto. Song leaving our Earth, we promised that on Mars the apple trees would bloom. Yes, how to save the planet? Theoretically it's possible. There are different ideas for terraforming Mars. Most of them boil down to saturating the atmosphere and creating a greenhouse effect. To do this, it is planned to turn frozen water and carbon dioxide at the poles into steam. But there is still a problem. It is elementary, everything will fly away again. Even if we create an artificial atmosphere on Mars, it will be blown away again by the solar wind. We need something more radical. We need some fantastic idea. And there is one, a powerful magnetic dipole. It must be placed at the Lagrange point of Mars. Lagrange points are the most interesting points. Points of gravitational equilibrium. The point we need is on the straight line between Mars and the Sun, and at the point where it is equally attracted by them. And most importantly, an object that is in this zone does not need an engine or fuel. It will fly according to the laws of celestial mechanics. And if a dipole protective screen shield is placed there, it will keep the solar wind off the planet. This will allow the atmosphere of Mars itself to revive. The frozen water beneath the surface will be able to melt, and seas will emerge. Mars will become warm, life will emerge, and we will be able to plant apple trees. It is interesting that creating this new world, that is, placing a dipole at the Lagrange point, can be done relatively quickly, in just a couple of decades. It is clear that so far this is a beautiful theory, but flights into space were once a daring dream. Recall the words of Tsiolkovsky. It's still only a fantasy, but behind it is an exact calculation. And because objectively Mars is the best planet for colonization, not to fly to Venus with its atmosphere of sulfuric acid, and not on Mercury with a temperature of plus 430 degrees in the shade. And if the colony on Mars appears in a couple of decades, then in a couple of thousand years a new human species, Homo marcius, will appear, and this new species will even physically look different. The weak gravity of Mars will make his bones, for example, become stronger through hypercompensation. And his skin color will probably be orange. The people of the future will still dream and look up into the sky. And if they happen to look toward the northern part of the sky on a quiet Martian evening, there they will see a bright dot with a blue hue. It is Earth, a small star, an unknown world that the people of the future may already have forgotten about. There will be rumors that they all supposedly came from that star. But when was that? And was it ever? While this little star of Earth still has a blue hue. While it has not yet become Mars, now we know what could happen to the planet, how it could even be. And this knowledge as a warning is probably the most important outcome of our mental experiment. Our mission to Mars. So, the way to space is open. But we'll be getting ready for new space routes. Stay tuned to Central Interplanetary Radio for more news.